Okay, we're going to pick up next. We did the parent graph of the sine function and we did the cosine function, and now we're going to talk about why those get to be called sinusoidal graphs. Now, if you look and focus in on this pink one alone, that's going to be our cosine function. That's the very last one we did. Remember, it goes through 0, 1. There goes, that's one cycle, period of 2 pi. Now, if you remember back to college algebra and transformations, this would mean shift to the right pi halves. So what I want you to visualize, if I pick this point up, this point in particular, and shifted it to the right pi halves and dropped it, it's right there on that blue graph, right? So now it's just continues on and on and on. Now, tell me, what does the graph of the blue one look like if I focus in from here, 0, 0, to here? It looks exactly like what? The sine function. So that's great. I'm glad you see that. So basically, what this is saying is the pink function, which we clearly know is the cosine of x, also can be expressed as the cosine of pi halves. I mean the cosine of x shifted to the right pi halves. They pick up and drop it. And that is basically the y equals sine x function. Okay, that's why we call these sinusoidal graphs. And we'll look at that a little bit more. So both of them have that nature, sine and cosine. Okay, so moving forward, the next thing we're going to look at is define amplitude and period. So I'm just going to say y equals capital A sine omega x and y equals a cosine x. Our amplitude, whoops, amplitude, can't write and talk at the same time, is defined by the absolute value of a because it's distant. So our value there is going to always be positive. In our period, sometimes it's denoted capital T, but we'll evaluate it by calculating 2 pi over W. Okay, so for a very, very basic idea, we're going to just focus on the amplitude first. The amplitude of this particular sine graph, y equals sine of x, is just going to be an amplitude of 1 because it's the absolute value of either distance from the x-axis to the maximum point there. So this would just be 1. What do you think the amplitude of this one would be? Absolute value of those, so it's just going to be 5. Okay, we're just going to start with this first example where we're going to do graph this function, y equals 3 sine of 4x. Clearly, it's not the exact same as the parent function, which would just be y equals sine of x, but we know it has similar properties. It has a different amplitude and a different period. Now, I'm going to remind myself of my formula. So it was y equals a sine omega x from my last screen when I defined amplitude and period. So we have an amplitude change and we have a period change in this problem that we're going to work. So if I was asked to graph this particular example, we know that we're going to have an amplitude. What's going to be our amplitude? So we would say amplitude is going to be absolute value of 3, which is just 3 units. Good. Okay, our period, we want to calculate, our period sometimes known as capital T, but it's by definition is 2 pi over omega. 2 pi, what is omega in our particular example? 4. Good, so 2 pi over 4. If we simplify this, we would just get pi over 2. Bless you. Pi over 2. Alright, so we're working with an amplitude, we're working with that. Now, I'm going to just try to, there's lots of different ways to do this, but I'm going to try to break it down into a procedure as much as possible. So we're going to try to pick maybe at least like 5 particular points, but we want to choose them. We're going to make an XY table. essentially, but we want to choose them so that they're evenly spaced. And the best way to do that is to take an entire period, remember that's a cycle all the way through, and let's divide it into 4 equal parts. So I'm going to say this is just to get my even spacing. I'm going to take my period and divide by 4. I'm going to make a note up here. So I'm going to say my period divide by 4, which if you remember doing fractions, that's pi halves times 1/4, which would just be pi eighths. So my increments, I'm just going to space out at pi eighths. So I would do x, y. I would start at 0. That's our first one. I would add pi eighths. Go over pi eighths because I want even increments. And then I would do pi eighths again. But where was my last place? So I took my last location, pi eighths, and I incremented pi eighths again. So I added pi eighths to it. So simplified, and my next x value that I'm going to evaluate is going to be pi fourths. Okay, and we want to take pi fourths, our last one, and we want to go over pi eighths. Remember our increment, and we're just going to add pi eighths each time to get evenly spaced points on our graph. So let's add pi eighths. I'm going to finish out this process to fill out this part of my table. So I'm going to pause it and do that. Okay, so check your work on that. Basically, we're going to start at 0, and we want to use our period to divide it into 4 equal parts so that we have nice, equally spaced x values. So when we found out our increment was pi eighths, you can see each time I just added pi eighths, added pi eighths, added pi eighths to get nice, equally spaced points. Now, the next thing we want to do is use our unit circle to pull this up to fill out the table just like we did in the previous example. Alright, with pulling this chart, remember we'll evaluate x, find y, plug it in as an ordered pair, and we evaluate that in the function that was given, which this is clearly not our parent function. So let's evaluate y equals 3 times the sine of 4 times 0, right? Well, what is 4 times 0? 0, good. And then 0, what is the sine of 0? So go to your unit circle, find 0. What's the sine at 0? Sine is the y value. So sine is 0. Good. That means this is 0. So sine of this is 0. What's 0 times 3? 0. So our ordered pair is 0, 0. Let's walk through the next one. 3 times the sine of 4 times pi eighths. Okay, 4 times pi eighths simplifies to what? Sine of 4 times pi over 8. If I simplified this guy first, that's just going to give me the sine of what? Pi over 2. Good. Sine of pi over 2. Let's go to the unit circle and find the sine of pi over 2. Pi over 2, what's the sine of that value? The y, remember? Good. So this is just 1. And then we have to, all of this simplifies to be 1. Well, what's 1 times 3? 3. So it's the order pair pi eighths comma 3. So this one has to do a little bit more scratch work, so be real careful and use order of operations. Our next evaluation is going to be y equals 3 times the sine of 4 times our x value this time is pi fourths. That's a pretty easy evaluation. The 4's will cancel, so we're just going to do sine of pi. So what is the sine of pi? Come to pi, what's the y value? 0, good, so that means all of this is 0. What's 0 times 3? 0. Whoa, let me undo that. 0, so we just get pi fourths comma 0. Okay, go ahead and do that with the next one. Let's do sine of 3/8 together. Y equals 3 times the sine of 4 times 3 pi over 8. 3 pi over 8 times 4. Okay, let's just do that. That's a bad 3. Okay, reduce this 4, divide by 4, so that's just going to give us 3 pi over 2. So what is the sine of 3 pi over 2? -1. Good. So that means all of this simplifies to -1. Well, what's -1 times 3? -3. So our ordered pair is 3 pi over 8, comma -3. And then our last one is pi over 2. 3 times the sine of 4 times pi over 2, which would just be 2 pi is here. That's going to give us 0. 0 times 3 is just 0. So we get pi halves comma 0. Our only task left to complete is to take these ordered pairs and plot them on, sketch them out. So let's pause that and do it. Okay, just checking our work and finishing up. Remember, the amplitude is 3 in this particular problem, and our period ended up being pi halves. So one full cycle happens in pi halves. And when we plot these ordered pair, this is what we should get. So this is our y equals 3 sine of 4x graph.